Welcome back to the deep dive. So our mission today, it's not just about reading blueprints or, understanding mechanical systems. We're going to try to cut straight to the core of what design really means in the 21st century.
We are. And we're looking at pretty fascinating stack of material here. We've got philosophers of technology, architects, ethicists, sociologists, and they're all kind of arguing the same thing.
Which is what?
That design is no longer just a technical or an aesthetic pursuit. It is fundamentally a philosophical and ethical force.
That's right. The core thesis here is that engineering, architecture, and now technology, they're all converging. They're all being driven by this one massive shared goal, shaping our entire material world.
And in doing so, they decide how we are designed to live.
It's a shortcut, really, to understanding the invisible rules that are embedded in the physical world all around you.
Right. And the discussion here, it moves past simply asking, does this product work, to something far more complex?
A much deeper question.
Exactly. The question becomes, what does this product do to our society, to our behavior, to our ethics? And to answer that, you have to treat all technical products as essential elements within what are called socio-technical systems.
Where the tech and the social structure are basically inseparable parts of the whole thing.
They're two sides of the same coin.
Okay, so let's start with the traditional boundaries. Let's see why they're, dissolving. For decades, the divide between the architect and the engineer seemed so clear. What was that dominant narrative?
Well, the tradition really dictated a pretty strict separation of roles. Engineers were the people who focused on physics and function.
They made things that worked.
That was the goal. They were masters of calculation and material science. Architects, on the other hand, their job was to order space, to provide visual expression, and to make the built environment livable.
But both were fundamentally different from, say, a fine artist, right?
Oh, absolutely.
Yeah.
And the similarity between architects and engineers is crucial here. They both design for material production, guided by a client.
A third party.
Or a collection of stakeholders, yeah. They don't just initiate a work based on some personal vision. They're solving external problems.
But even early on, that separation felt, restrictive. You think of the modernists. I love that historical insight from the 1920s when Le Corbusier was really championing the engineer.
He was so influential in arguing that, and this is a quote, "The engineer's aesthetic and architecture are two things that march together." He didn't just appreciate the look of engineering, he admired its whole approach.
He saw its efficiency as a model for design.
A model for modern design, yes. He saw that reductive, efficient aesthetic as the ideal.
And he tied that aesthetic to social progress, didn't he?
He did. He really believed that embracing these industrialized, efficient modes of production, the engineering approach, could do more than just improve the look of housing. He thought it could address deep societal issues, bringing good design and therefore better living conditions to everyone.
It was a fusion of form, function, and social justice.
A really powerful idea.
And if you fast forward 100 years, that convergence isn't just a philosophical suggestion anymore. It's a necessity. Why are modern engineers forced into the architect's territory as social consequence now?
Because today's technological capabilities are just so vast, they're too interconnected. When an engineer designs a complex system, a smart grid, an AI diagnostic tool, even a bridge, they have to constantly negotiate with all these competing stakeholders, environmental groups, community leaders, regulatory bodies. And when you're negotiating those trade-offs, you're not just dealing with physics anymore. You are dealing with ethical and social consequences. The job has become about managing the entire socio-technical system.
That brings us to one of the most fascinating concepts in this material, this inherent unpredictability of design. The philosophers call it the designer fallacy.
It's modeled on the literary intentional fallacy, the idea that a novel's meaning isn't fixed by what the author intended. The designer fallacy just applies this to objects. The artifact's ultimate use, its meaning, is not solely determined by the designer's original intent.
The object takes on a life of its own. It can even defy its creator. And you really can't talk about this without bringing up Thomas Edison and the phonograph. We all think of it as the beginning of music recording.
But that wasn't Edison's main idea at all. He conceived of the phonograph, which was advertised as the miracle of the 19th century, as a tool for business.
A dictation machine.
Primarily, yes, a primitive dictation machine. Music was a secondary thought at best.
So why did music win out?
Well, its limitations, funnily enough, dictated its ultimate use. The earliest phonographs used soft tinfoil, which degraded really quickly. You could only play something back for maybe 3 or 4 minutes before the recording just became unintelligible.
And that technical flaw.
It became embedded in the cultural landscape. It cemented the 3 to 4 minute length as the standard for a popular song, a standard that, lasts to this day. An unintended consequence dictated a generational cultural practice.
That's just amazing. A functional flaw literally transforms global musical culture. But the concept, it goes even deeper than just unintended use. It's about cultural embedding. The object itself stays the same, but its reality changes drastically depending on where it lands.
Take the windmill. Abstractly, it's a wind-driven device for converting energy. But historically, that same technology was culturally embedded in profoundly different ways.
How so?
In India, for example, it manifested as an automated prayer wheel, a religious artifact. In Mesopotamia, it was used for milling grain. In Holland, it became essential for land drainage, for reclamation.
And you'd argue that calling these just different uses is too simplistic. It abstracts away the real complexity.
It does. It completely ignores the fact that the entire local economy, the social structure, the belief system, all of that dictated the form and function. Today, a high-tech Danish windmill, 100 meters tall with self-governing blades. It's materially unrecognizable from a small prayer wheel.
But they're both wind-driven devices.
Fundamentally shaped by their socio-technical context, yes. So if design is this powerful, this embedded, and this capable of mediating our experience, even against the designer's wishes, then we have to accept a pretty provocative idea that artifacts themselves possess a form of morality.
Yes. The material argues that technologies embody scripts that prescribe certain actions and, discourage others. We aren't saying the artifact has consciousness,
Of course not.
but it possesses intentionality in the original Latin sense.
Yeah.
Tender to direct, to point towards something.
Give us the clearest analogy of that script in action.
Okay, think about mandatory design features, a shopping cart with a coin lock, for instance. It materializes a moral script.
Which is?
If you want to use me, you have to put some effort into returning me. Or a speed bump. A speed bump embodies the script. Slow down before you reach this point. Designers are literally materializing morality.
Or, to use that more evocative phrase, they're doing ethics by other means.
They're baking choices right into the steel and the concrete. So every single design choice, no matter how small, is a moral decision, whether it's conscious or not. Let's look at the ethics of this across different scales. Maybe move into organizational responsibility. The material divides the design process into two categories, normal and radical.
Right. So in normal design, the operational principle is already established. The configuration is a given. If you're designing standard components for a pre-existing bridge type or some chemical piping, the ethical issues are mostly managed through regulative frameworks.
So laws, standards, safety rules.
Exactly. You're relying on legislation, technical standards, certified safety rules. The criteria for safety are prescriptive, and they're operationalized by these existing standards.
That sounds a lot like checking boxes to meet compliance. But what happens when the boxes don't exist? That's where radical design comes in.
Exactly. Radical design happens when the operational principle or the normal configuration is not given. For example, designing a completely new, sustainable, lightweight car that has just never been built before.
So there are no frameworks.
Or they're absent or they're inapplicable. So the design team has to rely primarily on its own internal design team norms and, frankly, their own moral imagination.
What's surprising to me is that these small, almost invisible design choices made in normal design can carry just massive macro-ethical consequences.
Oh, they absolutely can. The source material points out that setting the default option on an office printer or a copier to one-sided versus two-sided seems like such a trivial technical detail.
I've never even thought about it.
Right. But when you scale that across millions of machines worldwide, that single default setting has enormous global ethical consequences. Paper consumption, sustainability, energy use. Moral values are constantly at stake, even in the smallest UX choice.
And sometimes, for radical design to happen, innovation actually requires a moral rejection of the current framework.
We see this in the story of the lightweight car team. They rejected the Euro NCAP crash tests, the existing regulatory framework, because they believed those tests stressed occupant safety at the expense of fuel efficiency and sustainability.
They disagreed with the values embedded in the test itself.
They felt the current standards embodied a value system they just didn't agree with. And that moral rejection, that's what led them to innovate a completely new design approach that tried to balance these competing goods.
This connects so well to the macro ethics of organizational culture. I mean, historical disasters like the Challenger accident show that defining acceptable risk isn't a purely objective mathematical exercise.
No, it's deeply, deeply rooted in the organization's shared technical culture. With the Challenger disaster, the decision to launch wasn't based on a lack of technical data. The engineers advised against it.
They knew the risk.
They did. But the final decision was traced back to what's called a normalization of deviance within NASA's technical culture.
What does that term normalization of deviance mean in practical terms?
It means that over time, the organization slowly accepts marginal anomalies and failures, like O-ring leakages at lower temperatures, as normal or as non-threatening. It essentially shifts the acceptable baseline of risk without any formal acknowledgement.
So for Challenger, the engineers who opposed the launch, they failed to meet the criteria to reverse a decision.
Right. The organizational system made it easier to launch than to stop. It shows that technical knowledge was situated, it was dependent on the management culture.
And then there's the infamous Ford Pinto case, which shows that the decision about safety wasn't even technical in the end. It was purely managerial and financial, but embedded in the car's design.
Correct. The Ford decision to not implement a cheap safety fix was based on a cost-benefit analysis that literally put a price on human lives versus the cost of a redesign. The point here is that safety is a social decision embedded in the design process itself, not just a technical outcome.
If design is so easily shaped by situated culture and values, how do we stop the entire system from just getting away from us? And that leads us into the limits of human experience, phase 4. We are constantly swimming in this public discussion that's dominated by the discourse of inevitability.
That phrase, adapt or you're toast, it's everywhere. It propagates this idea that technology is some autonomous force that we merely respond to. This feeling of determinism, it starts with what's called technological drift.
Where we just naturally solve problems that are susceptible to technological solutions.
And that drift builds into what's called technological momentum.
And that momentum, that feels like fate in our everyday lives.
Precisely. I mean, every time you're forced to conform to a software update or a required app or a computer interface that dictates your workflow, you are experiencing the power of technological momentum. It feels deterministic.
The antidote, the source it suggests, is a compelling discourse of design, one that re-emphasizes choice and human intention. And you can see this tension played out in the marketplace.
Absolutely. Compare the Apple iPod to an equivalent Dell MP3 player from the same era. Dell marketed theirs as a pure commodity efficiency, speed, lower cost, conforming to an established path.
And Apple?
Apple marketed the iPod based on originality, aesthetic design, and the seamless integration of technology into creative human choice. One is a discourse of commodity. The other is a discourse of human ingenuity and intentional design.
Okay, here's where it gets really, really interesting for me. High-end design is now fundamentally changing the nature of technology itself. We're shifting from nature technologized, forcing nature into a machine mold, to technology naturalized.
This is the field of biomimetic engineering, where technology tries to emulate natural systems. Think of synthetic biology or advanced material science that tries to replicate biological processes. It sounds benign, but it introduces a new kind of danger. Noumenal technology.
What exactly is noumenal technology and why is it so dangerous?
It's technical agency that unfolds below or above human thresholds of perception and control. Think of nanoscopic sensors or genetically modified foods where the technical intervention is invisible and operates completely outside our normal frame of reference.
Unlike older technologies.
Right. Unlike a visible factory polluting the air or a streetcar that you can count on being present, you may not perceive the presence or the absence of noumenal technology.
So, because we can't see it, it behaves like what we used to call uncivilized nature. It's opaque and unrationalized, and that complicates our ability to assign responsibility.
Exactly. When the agency of the design is invisible, it becomes profoundly difficult to monitor or to control or even to debate its ethical implications in the public sphere.
And that sets the stage for the ultimate design dilemma: redesigning humankind itself. We have some dramatically opposed viewpoints on this future.
On one side, you have proponents like the cyberneticist Kevin Warwick. He fully embraces merging humans with technology, electronic implants, sensory extensions. He sees the cyborg future as the next logical, even necessary step in human evolution.
To increase speed and communication.
For them, it's a massive design opportunity.
But the critics warn against this rush, particularly when it comes to genetic enhancement.
They do. They argue that the hopes and the fears of creating a new species of post-humans are often based on a fundamental flaw, a really inadequate understanding of human biology, specifically the dangerous idea of genetic determinism.
Which means what, exactly?
It's the over-exaggeration of the role of genes as the sole factor in determining complex human traits and behaviors, while ignoring the massive, proven influence of social, cultural, and environmental factors.
And the danger is that we misallocate our energy.
The danger is if we fall into genetic determinism, public policies will emphasize expensive genetic interventions over making crucial, difficult changes to social structures or lifestyles. We'd be fundamentally misallocating our design energy.
So if we look across this entire spectrum, from a simple speed bump all the way to the prospect of post-humans, what have we really learned about the nature of design?
I think we've learned that the complexity of design across all disciplines and all scales is that it is fundamentally axiological.
Okay, let's break that word down for everyone listening. What does it mean for design to be axiological?
It means it's value-laden. Design embodies our collective values and our intentions, our fundamental desires about how we believe we should live.
Whether we choose those values consciously or not.
Right. Whether we arrive at those intentions consciously through rigorous debate, or we just sort of create them by default through organizational inertia.
So if design has to embed our values, how do we make sure the design is successful out in the real world?
Well, architectural common sense provides a good heuristic here, a good starting point. Successful design always strives to make projects work in context. The philosopher John C. Pitt suggests criteria should be based on common sense design, where the space should fit the space it is in.
Drawing on historical knowledge.
Drawing on historical knowledge of successful action within that specific environment.
It's not about being nostalgic, it's about being grounded.
Exactly. It looks to the future by building on proven actions. It only incorporates new materials and technologies if they demonstrably solve existing unresolved problems without sacrificing essential values.
So we've established that technology is not a neutral instrument. It's an active mediator, it materializes morality, it shapes the very limits of our perception. If we accept that the complexity of modern systems often leads to unintended consequences and this normalization of deviance within technical culture, then we have to ask a final question.
What new forms of public participation are required to ensure that technological design choices, especially in these nascent fields like bioengineering and nanoscopic technology, reflect the values and the needs of the citizens they ultimately shape?
Because if the design is axiological,
Then the ethics must be participatory.
something to mull over as you navigate your own socio-technical system today. We'll see you next time on The Deep Dive.